Do you believe there's life out there? And no, I'm not talking about little green men. Just life. Well, NASA once ran an experiment on Mars that found the evidence for it, and then pretty much buried the results. We also know that there are ancient coastlines and caves big enough to hide actual biology today, and yet it hardly makes the news. If that kind of silence makes you curious, well, make sure to hit like, subscribe, and turn on that notification bell so you don't miss more lists just like this one. Because I'm Mike with List 25, and these are 25 things NASA doesn't want you to know about Mars. 25. There's probably life on Mars right now. When people think about Martian life, they usually picture fossils locked in rock or microbes that died out billions of years ago. But there's a chance it's still around today. Mars's dusty ice sheets absorb sunlight, creating tiny melt pockets just a few feet down. Enough light filters through for photosynthesis, and on Earth, meltwater like that is crawling with fungi and microbes. Now, strangely enough, NASA's own experiments once hinted at the same thing. In 1976, NASA's Viking mission tried something simple. Feed Martian soil a radioactive nutrient cocktail, and wait. If anything alive was in the dirt, it would consume the food and release gas. To everyone's surprise, that's exactly what happened at both landing sites. But Viking's other instruments, built to look for organic molecules, came up empty. Instead of chasing the contradiction, NASA called it, quote, just a chemical reaction, and downplayed the life angle. But the data never really went away. 24. We might have found life, and accidentally killed it. As you can imagine, Viking's data has always been very controversial with scientists, both making the case for and against possible life. But some scientists now argue that Viking didn't just detect life, it also immediately destroyed it. Their reasoning makes a lot of sense. If Martian microbes do exist, they'd be adapted to extremely dry conditions. Viking added liquid water to the soil, which could have been toxic to anything used to dryness. Worse, the landers also baked some of the samples to test for organics. If fragile organisms were in there, that heat would have wiped them out completely. That could explain why Viking's results were positive in some cases and negative in others. 23. Methane spikes at night. The Curiosity rover has been sniffing the air at Gale Crater since 2012, and Strange doesn't even begin to cover it. Every night, methane levels spike, and by day, the gas disappears. It's happened again and again. At one point, the rover even recorded a massive spike, more than 20 parts per billion, before it disappeared days later. On Earth, methane is usually linked to life. NASA, though, says the gas just pools in the crater overnight and gets stirred away when the sun comes up. Maybe that's true. But it sidesteps the bigger issue. If methane is leaking from the ground, something is making it. 22. The carbon isotopes don't add up. Curiosity has also been digging into Martian rocks, and the carbon it's found isn't what anyone expected. Some of the samples they tested were loaded with carbon-12 and missing almost all carbon-13. So, carbon that's incredibly light by Earth standards. The only place we see that kind of signature here on Earth is in ancient sediments that were shaped by microbes billions of years ago. So, how did NASA cover it? Instead of saying possible life, they leaned on sunlight, chemical reactions, maybe meteorite dust. Technically, it could be. But the numbers are so extreme that life has to be part of the conversation. 21. Oxygen levels rise and fall in all the wrong ways. NASA has been tracking Mars's seasonal differences forever. And another thing that doesn't fit is the changes to the planet's oxygen. During spring and summer, it jumps up by about 30% and then falls right back by, well, fall. Scientists have run down the checklist of explanations. Sunlight splitting water molecules? Not enough water in the air. Dust reactions? Too small to explain the swings. Even the seasonal freezing and thawing of carbon dioxide at the poles can't explain the numbers. The oxygen data gets even stranger when you set it next to the methane record. Sometimes both gases shift at the same time. That doesn't prove anything, but oxygen and methane living side by side is almost always the work of microbes. 20. Mars could have had its own Yellowstone. Yellowstone's rainbow-colored hot springs get their color from living things. Heat-loving microbes like to colonize different zones depending on how hot or acidic the water is, and their pigments light up the pools. But here's the part that matters. Billions of years ago, Mars was taking direct hits from massive asteroids. Some of the biggest impacts were hundreds of miles wide and generated enough heat to turn parts of the crust into long-lasting hydrothermal springs. That's not mere speculation. Researchers have found geological signs suggesting hot springs once formed in those old craters. And where there are springs, there are nutrients. Think sulfur that certain microbes love. If anything had a shot at surviving the atmosphere on early Mars, these springs would have been its best chance. 19. They discovered a liquid lake, then backpedaled. In 2018, a radar instrument called MARSIS picked up something weird under Mars's south pole. Something that looked an awful lot like liquid water. It was buried more than a mile down, stretched over 12 miles wide, and showed the kind of bright radar signal you'd expect from a subglacial lake. Naturally, the headlines went wild. I mean, water on Mars. But over the next few years, what got published argued that the signal might have come from something else completely, like salty sediments or frozen clay. NASA and ESA didn't kill the story, but they did start toning it down. These days, the lake is possible brine, slushy sediment, or just the right mixture of minerals to fool the radar. So, more of a maybe, and even that is controversial. 18. Mars might have had a volcanic eruption just 50,000 years ago. For a planet that's supposed to be geologically dead, Mars sure isn't acting like it. In 2021, scientists spotted a strange dark patch in Elysium Planitia. It didn't look like the usual lava flow. It was smoother, fresher, and a whole lot more explosive. They didn't realize it at the time, but they had just uncovered Mars's youngest known volcanic eruption. We're talking maybe 50,000 years ago, which is basically yesterday in geologic time. The eruption sent ash 6 miles into the air and came from a huge fissure near Cerberus Fossae, where the Mars quakes are still continuing to this day. Some researchers now think magma could still be moving down there, and if magma mixes with underground ice, you've suddenly got warmth, water, and nutrients in the same spot. 17. Mars used to be warmer and wetter. Some discoveries only happened because the scientists decided to zap the right rock. Roger Wiens and his team spotted an unusually pale boulder in Jezero Crater, so they had the Perseverance rover fire its SuperCam laser at it. What came back wasn't just neat spectroscopy data. The rock turned out to contain kaolinite, a clay mineral that only forms in warm, wet, or hydrothermal environments. Even better, they didn't just find one. They found over 4,000 of these pale rocks scattered around the crater's rim. Kaolinite shows up when water lingers long enough to strip away iron and magnesium, leaving aluminum-rich clays behind. So it's a pretty strong indication that Mars wasn't always the frozen desert we see today. And if the planet really went through long, warm, and wet stretches, there's a good chance that a few life-friendly underground pockets survived far longer than anyone expected. 16. Mars also had beaches and shorelines. Mars wasn't just warm and wet. It used to look like a seaside postcard. Before China's Zhurong rover went silent, it managed to detect underground deposits, evidence of sandy beaches, wave-washed sediments, and even the kind of layering you'd expect to find next to an ocean's edge. However, it must be said that the evidence is about 3.6 billion years old, and comes from the time when Mars still had enough water to manage waves, rivers, and currents. Today, all that's left is desert. But Zhurong's data shows that back then, the waves were basically stirring up the soup for life. 15. Mars might be hiding an underground ocean. I mentioned Marsquakes a bit earlier, but just in case you don't know, they're basically exactly what they sound like. The Martian version of earthquakes. Small tremors in the crust caused by shifting rock or even magma moving underground. In 2024, Vashon Wright and his team used seismic data from NASA's InSight lander to see how those quake waves move through Mars's crust. What they found is huge. The planet could still be loaded with water. Their models suggest enough liquid trapped underground to cover the whole planet with an ocean 1 to 2 kilometers deep. Now, it's not some giant hidden sea. The water is locked in microscopic pores and cracks 7 to 13 miles down, way too deep for us to reach with all the technology available to us right now. But the seismic evidence is solid enough that most scientists now agree Mars is far more water-rich than NASA usually lets on. 14. Caves big enough to hide life. In 2007, the Mars Odyssey orbiter spotted a cluster of 7 giant pits on the side of the Arsha Mons volcano. Scientists nicknamed them the Seven Sisters, and quickly learned that their thermal signatures showed they stayed cool during the day and held on to heat at night, which only makes sense if they open into deep caverns below. Some of these skylights stretch more than 200 meters, about 656 feet, across, and at least one drops over 100 meters, around 328 feet, straight down before hitting the floor. NASA has admitted these caves could be prime spots for biology to survive, but there hasn't been much follow-up because they're located high on a volcano and out of reach for today's rovers. 13. Mars had mega-tsunamis. You have to believe Mars once had an ocean to make sense of this next one, because without water, the evidence for mega-tsunamis simply doesn't make any sense. Several researchers, including Alexis Rodriguez, have uncovered evidence that around 3.4 billion years ago, asteroid impacts in Mars's northern ocean triggered two massive tsunamis. They also carved channels, laid down lobe deposits oriented upslope, and dragged ice and boulders far inland, which floodwater alone cannot do. At some sites, wave heights may have reached 50 to 120 meters, 160 to 400 feet, and spread across many hundreds of kilometers. 12. Mars went through a recent ice age. We call it the Red Planet, but not that long ago, Mars would have been mostly white. Radar scans from the Mars Reconnaissance Orbiter let scientists peer 2 kilometers beneath the northern polar ice cap. What they found were frozen layers stacked like pages in a climate diary, and the message was loud and clear. Mars went through a vicious ice age about 370,000 years ago. That might sound ancient, but on the planetary clock, it just happened. And it's not done. According to their models, another ice age is already on the way, expected to hit in about 150,000 years. 11. It has strangely strong magnetic fields. Mars lost its global magnetic field billions of years ago. Or so everyone thought. Then InSight's magnometer got a reading from the surface and flipped everything on its head. After it landed at Homestead Hollow, the magnetic readings were almost 10 times higher than any satellite ever recorded. That points to deep crustal rocks that could have held onto their magnetization for billions of years. Scientists think that those rocks never reheated after Mars's dynamo shut down, so they kept their charge. NASA is firmly adamant that these must be anomalies. But for anyone hunting clues about Mars's lively past, they're solid leads. 10. We may have already found life. Again, decades after the 70s Viking experiments left everyone wondering if we'd killed innocent Martian microbes by accident, Perseverance's findings hit the news again in September 2025 with evidence that was just as provocative. In 2024, while exploring the ancient river valley of Nerevtavalis, the rover drilled into a rock called Chayava Falls and pulled up a sample named Sapphire Canyon. Inside were tiny leopard spots, mineral reaction fronts made from vivianite and greigite, minerals that usually form around microbial activity. These sediments are young by Martian standards and packed with the raw ingredients microbes would need: organic carbon, sulfur, phosphorus, even oxidized iron. For the first time, NASA admitted it could be a potential biosignature, but they backed off before dropping the L word. 9. They keep saying they're going to Mars, but they can't afford it. Every time NASA rolls out plans to bring humans to Mars or bring Martian samples to Earth, there's a number attached. Billions. Not little billions. Really big ones. The Mars sample return mission was sold as costing $5 to $7 billion, with samples arriving by the early 2030s. Now, internal reviews peg the cost at $11 billion, and the return date has slid all the way to 2040. To keep the dream alive, NASA is redesigning MSR, cutting pieces and pushing deadlines. Congress is eyeing deep cuts to NASA's science budget, which means other Mars missions, or even instruments, could be delayed or canceled. The reality is that their going to Mars news is starting to feel more like a wish list than a plan. 8. There's a risk of Back-Contamination. There is a low, but very real risk that Mars samples returned to Earth could carry unknown organisms. Now, NASA and ESA are not ignoring it at all. They're actually designing multi-layer containment systems, a sort of container inside a container to ensure that Mars material stays sealed at every stage. The mission is also classed under the strictest planetary protection rules, COSPAR Category 5, which means everything from launchpad sterilization to facility quarantine has to be accounted for. But if any component fails, whether it's a breach in a container, re-entry damage, or human error, that is when Back-Contamination becomes dangerous. Scientists believe the chance of release is very small, especially because many of the samples are from extremely dry, irradiated surfaces that are less likely to support life. Still, this risk is built into every safety plan. 7. Mars is swarming with dust devils we can't see. Mars is crawling with vortices, pressure dips, spins, mini whirlwinds. In fact, more than we ever guessed. InSight sensors picked up thousands of them, perhaps over 10,000 vortex events, and yet no camera has captured a single fully active dust devil in view. The reason is that a lot of them don't carry enough dust to be visible. Lighting, angle, and timing, all of these factors work against a clean photo. If there's no dust in the wind, you'll see a signal, but not a shape. Nobody disputes the readings, but the agency's take usually slips into the background as short caveats. Dust lifting uncertain, or visual confirmation rare. Figuring out Mars' atmosphere and how safe it is to land and work there depends on whether these unseen whirlwinds are the exception or the norm. 6. The solar wildcard. The early sun spun faster, flared more often, and threw out radiation that would have made today's solar storms look tame. For Mars, that meant non-stop exposure, since the planet had already lost most of its magnetic shield. The challenge is that we don't know the exact timeline. Did these solar blasts strip Mars in a geological instant, or did they keep chewing away for ages? Even with MAVEN's data and computer models, the numbers swing wildly depending on assumptions about solar output and Mars' own atmosphere. That uncertainty makes it nearly impossible to pin down when the planet crossed the line from habitable to hostile. 5. Our missions are extremely fragile. In 2018, Mars kicked up a storm so enormous that it wrapped the whole planet in dust. What started as a regional event in May grew until, by June, the skies were pitch black. The Opportunity solar panels couldn't pull in enough sunlight to charge, the batteries drained, and the rover went quiet. The storm cleared by October, but Opportunity never answered back. After months of silence, NASA officially ended the mission in February 2019. For a rover that was only supposed to last 90 days, it had already gone more than 14 years, which is impressive. Nevertheless, the 2018 storm reinforced just how fragile solar-powered missions can be on Mars. 4. A planet of rivers. If you're looking for life, rivers are always a good place to start. They carry minerals and sediments and mix everything together in ways that make biology more likely. Unless it's Sam Rivers from Limp Bizkit, I don't think he does any of that. But that's why a Penn State team's new study is hard to ignore. They've branded Mars a planet of rivers. Using satellite images, Curiosity rover data, and 3D scans from Earth, they showed that certain landforms, the so-called bench and nose shapes inside the planet's craters, are actually the eroded remains of ancient rivers. Until now, those features weren't even linked to flowing water. So Mars wasn't just a warm and wet world with water here and there. Rivers may have been the rule, not the exception. And the more rivers we uncover, the harder it is to avoid the question, what might have lived in them? 3. The blobs. In September 2024, scientists at the Europlanet Science Congress in Berlin revealed the first full gravity map of Mars. The new model, built from satellite orbit shifts and seismic data, showed about 20 mysterious underground blobs clustered under the planet's north pole. One even looked like a dog, which quickly earned it the nickname the Martian Dog. They all lie inside the Borealis Basin, that area so many people believed used to be a sea and are roughly 300 to 400 kilograms per cubic meter denser than the crust around them. Nobody knows what they are. They might be hard magma from volcanoes or compacted impact debris. Maybe something else nobody thought of. There's no sign of them on the surface, and the only reason we know they exist is because their gravity pulls passing satellites just slightly out of place. 2. NASA keeps putting off important missions. Some of the places where life might still be hidden on Mars are the harsh ones. The polar caps, hydrothermal vents, and deep underground. NASA has talked about sending rovers to those spots, but often never follows through. Take the Astrobiology Field Laboratory, for example. It was supposed to land in 2016 in one of those extreme environments, maybe a polar site or hydrothermal deposit, and look for signs of life. It never got funded. Then there was the Max C canceled in 2011 that also aimed to test habitability more aggressively. These delays and cancellations leave huge gaps in what we know. Most of the rovers we have landed avoided the coldest, most dangerous places. Because of that, our picture of where Mars might support life, past or present, is based on safer, warmer, more accessible locations. 1. The MPX experiment. Among the payload ideas from Mars 2020 was one of the most creative, and possibly helpful in the long run, ideas ever. Scientists wanted to send a shoebox-sized greenhouse to Mars to see whether anything alive from Earth could sprout and survive, even briefly, under Mars's conditions inside a sealed, safe chamber. But when the mission payload got chosen, MPX didn't make the cut. That means we lost direct data from extreme tests. Things like what plants really do under real Martian radiation, cold, thin atmosphere, and low pressure. Because of that, when NASA talks about habitability, they're talking about conditions we know are safe or predictable, not the zones where life tests like MPX would push the limits. It's one of the clearest signs that when living tests are on the table, NASA plays it safe, and that choice could be holding us back. And that's a wrap. What do you think? Should we cut NASA some slack? I mean, I'm not even sure I'd want to go to Mars. How about you? Alright, moving on. Let's see if you were paying attention. Curiosity has been sniffing the air at Gale Crater since 2012 and keeps catching a gas that spikes at night and then fades by day. Which gas is it? Is it A, oxygen, B, nitrogen, C, methane, or D, argon? Drop your answers in the comments below. And if you're just getting started, you'll love our related video 25 science theories that are so strange they must be true. It's got everything from a universe with consciousness to mirror worlds and even your gut calling the shots. That link will pop up about right here. Thank you guys so much for watching. As always, like I said before, like, share, comment, subscribe, notification bell, and I'll catch you guys for the next one. We're gonna blast off, baby, to Mars.